So we've looked at vertex form of parabolas. Today we're going to look at intercept form of parabolas, which is just a slightly different way that you can write an equation. All right, so this is our general form up at the top here that tells you what the intercept form of parabolas look like. Right, and this gives you some key features just like vertex form does. We call it intercept form because it gives you your x-intercepts. So it's intercepts specifically, it gives you the x-intercepts. Right? And finding those is really easy. It's just at whatever P and Q are. So whatever these two numbers are. But just like in vertex form, you notice how there's a minus sign built in. Okay. What that tells me is that these are actually going to look backwards of what they actually are. So our two x-intercepts for this equation are going to be P comma 0 and Q comma 0. But just like before, these, right, the P and Q part are going to look backwards. Okay, so if it says plus 3, it's actually going to be a minus 3. If it says minus 5, it's actually going to be a plus 5. All right, the second thing that we can tell is we can tell if this is going to have a minimum or a maximum. And it's actually exactly the same as vertex form. Okay, it's this A number in the front. And if this is a positive number, then your graph's a U shape and it has a minimum. If it's a negative number, it's an N shape and it has a maximum. So it's a minimum, right, which would happen when your graph looks like this. And that happens when A is positive. Okay, and the maximum happens when your graph looks like this. And that happens whenever A is negative. So far, really easy. Now, the one thing about this that actually is a little bit harder than vertex form is to find the actual vertex of this guy. So to find your vertex, what you have to do, right, is there's kind of two steps to it. Step one is you have to find halfway between P and Q. All right, and the easiest way to do that is you can use a little formula if you want to, where you just do P plus Q and divide it by 2. Or if you have a graph, you can just use your graph and find halfway between them. So we're going to do it both ways. All right, and then the second thing that you're going to do, this just gives you your x coordinate. So that tells you the first part of your vertex where the x coordinate is. Then you have to find the y coordinate. So then what we're going to do is we're going to plug that previous answer, that number over there, in for x, right? And solve for y. And that's going to give us both coordinates of our vertex. I know that sounds really confusing right now, but once we do an example or two, it's going to make sense. All right, so let's take a look at our two examples. So the first thing that I need to figure out is what are my x-intercepts for this graph. So first thing is our x-intercepts. And for this one, it's these two numbers, but they're backwards of the way they look. And we're writing them as points. X-intercepts are always, the second number is a 0. So this one is going to be the 0.30. And then the other one is going to be the 0.10. So even though it looks like a minus 3, it's a positive 3. Even though it looks like a minus 1, it's a positive 1. So that's what I mean when I say backwards. All right, this one, since the 2 is positive, that tells me my graph is going to look like this, and it's going to have a minimum. So my graph is going to open this way, and it has a minimum. All right, and then to find the vertex, so this is the one that's going to take a little bit of work. So the first thing that I'm going to do is I'm going to find halfway between P and Q. So I'm going to take these two numbers here, the backwards looking ones. I'm going to add those together and then divide it by 2. All right, and that's how I'm going to get my x coordinate. So 3 plus 1 is 4. 4 divided by 2 is 2. That's the x coordinate of my vertex. And then I'm going to go back and I'm going to plug that into this equation for x. It's actually going to get plugged into 2 different spots. So it's going to get plugged in here and there. Okay, so I'm going back to my equation, and it's going to be y equals 2 times x is the 2 we found here. So 2 minus 3. And then again, x is the same 2 that we found, 2 minus 1. All right, and then we just have to calculate this. So 2 minus 3 is negative 1. 2 minus 1 is 1. And that 2 is chilling out in the front. And I'm just going to multiply those 3 numbers together. So 2 times negative 1 times 1 is negative 2. So my vertex is going to be the point with an x coordinate of 2 and then a y coordinate of -2. That's my vertex. Okay, so that's my last answer there. That's the only hard part about vertex form, is it's just a couple of steps there. All right, so let's do it again with this one. So first off, our x-intercepts. So again, backwards of what they look like. And the second number is always 0. So the first one, it's not +5, but it's going to be -5, 0. And the second one, it's not -1, it's +1, 0. So it's backwards of what it looks like. All right, our a value at the front, even though there's no number there, it's still negative, right? So that tells me that my graph is going to open down, makes an N shape, which means that I have a maximum. All right, and then to find my vertex, I'm going to go halfway between these two numbers. So my x coordinate, I'm going to do -5, this guy, +1, this guy, and divide it by 2. So -5 plus 1 is -4. -4 divided by 2 is -2. So there's the x coordinate, and then I'm going to plug that back in for both x's in my equation. So it's y equals negative, and then in parentheses, I'm plugging in that -2 for x, plus 5. And then I'm plugging in that -2 again for x. -2 plus 5 is 3. -2 minus 1 is -3. So negative times 3 times -3 works out to +9. So my vertex has an x coordinate of -2 and a y coordinate of 9. And there we go. And we're going to practice a bunch of these in class. You're going to get it pretty quick. It's not going to be that bad. All right, so now a little mini application here. So ball, we get a ball that goes up in the air and it falls along this path. So we're going to start by diagramming this, and we're going to add in whatever numbers we can in our diagram. So the ball is going to go up in the air and then it's going to come back down, right? So what do I know about this? Well, the first thing I know is this is an intercept form. It doesn't look like it's an intercept form, right? Because usually like intercept form seems to have these two sets of parentheses, right? And this one doesn't. So it doesn't look like it's an intercept form at first, but it actually is. It's just that with this x right here, what this equation looks out like in the long way is it's x minus 0 times x plus 10. But like we don't bother to write minus zeros because they don't do anything, right? So this is like the long way of writing the equation, but this is like the short way. So what this is telling me is that my two intercepts are going to be at 0 and -10. Okay, well, that's a little bit weird. That's actually a typo. We're going to have to fix that. Sorry, this was supposed to be x minus 10. Okay, typo fixed. So my two x-intercepts are now at 0 and +10. So that tells me that this end where it hits is at 0 and that this end over here is at 10. Okay, my vertex, if I want to find that, right, the vertex is in the middle, it's symmetrical. So this is what I was talking about before. You can either do 10 plus 0 divided by 2, or you could just kind of say, well, what's halfway between those two? 5, right? 5's halfway between. And if I want to figure out how high this goes to find the actual rest of the vertex, I'm going to plug 5 into my equation for x. So if I come back to this, it's going to be y equals -1/2 times 5 times 5 minus 10. 5 minus 10 is -5. So then I'm multiplying -1/2 times 5 times 5. And if I throw all that in the calculator, that works out to 12.5. Okay, so that tells me how high up the ball went. So what I can look at from this graph right away, the things that it tells, right, is I know that I start at 0 and I end at 10 when it hits the ground. And the highest height that it ever gets to is 12.5 feet or whatever these units are. Okay, so when this question asks me how far does the ball go before it lands, well, from here to here, how far is that? 10 units, right? So it went 10, we'll go with feet for this one, feet, yards, something like that, right? That's how far the ball went. Okay, if it asks you how high the ball went, 12.5 feet. Okay, so that is intercept form. We're going to practice this a bunch so you'll get used to it, right? But it's just a different form of a parabola that just highlights some different information than vertex form does. That's all.